Now I will explain you the machine cycle of bus idle condition. Now for this bus idle condition, I have taken an instruction DAD. D-A-D. It is an arithmetic group instruction. In this instruction DAD, what happens? A register pair content is being added with HL contents. That means HL is a register pair in which we add another register pair contents, and the result will be again stored in the HL register pair. Now for DAD instruction, it is a 1 byte instruction. Now for 1 byte, there is only one machine cycle, that is opcode fetch. So for this special type of instruction, DAD instruction, we are also having one more machine cycle, that is known as bus idle machine cycle. In this machine cycle, what happens? In this, internal task of addition is being done because register pairs are being used, so more than 8-bit is being added. In this, 16-bit addition would be there and 16-bit result would be stored in the HL register pair. So for that purpose, for 1 byte instruction, this is not only opcode fetch, but one more machine cycle is used, that is bus idle. In this case, there is no to and fro movement of data from memory or IO. That means there is no input or output of data from memory and IO. But all the buses are idle. They are not in use. But there is an internal task of addition which is done by ALU. So opcode fetch would be the same, that is for 4T state, and the diagram of the opcode fetch will be the same. In this diagram, what happens? In case of opcode fetch, the higher order address bus is being loaded from where the opcode is being fetched, and the lower order address bus is also fed with that. Then the opcode is being copied from the memory address and it is being read by this read instruction. So this is all about opcode fetch. Now what happens to the next machine cycle? It is basically no address and data buses are being used. So data bus in the tri-state form and at higher order address bus is in the unspecified form. Now this is the IO by M bar and the status. All are 0 for the bus idle condition. And there is no read signal, there is no write signal, but there is an interrupt acknowledgement signal. And it means there is no interrupt acknowledgement signal. There is no interrupt acknowledgement signal. This means INTA bar is basically 0 to activate interrupt acknowledgement, but there is no interrupt acknowledgement, so whole buses are in idle state. No input output, no read write, nothing is there in the microprocessor, but only arithmetic logic unit performs its task. So for that task, it requires bus idle condition. This bus idle condition are for 6 T states: T1, T2, T3, T4 and T5, T6. Now these are the 6 T states, and in these 6 T states, all of the buses are not in use.